This is a video on using an applet that has exercises for understanding and practicing the normal distribution and the central limit theorem. So the question states, if x follows a normal distribution with mean 10.9 and standard deviation 22.0, find the probability that the average of 3 items with this distribution is greater than negative 12.0. So our first step, as it tells us, is to determine the correct distribution for this problem. Notice we want to find the probability that the average of 3 items with this distribution is greater than a number. If I click this little arrow that has the x, it gives me 3 choices: x, x bar, and sum of x. X corresponds to looking at the probability of a single individual. X bar is the sample mean, so we're talking about the average of individuals. And sigma x is the sum of the x's, and that would be had we wanted the sum of the items values. We want the average, so I click X bar. Next, I want to find out what is the mean and what is the standard deviation. In this notation, this tilde n, that means it's approximately normally distributed. And the next item is the mean, and the following item is the standard deviation. So the mean of the sampling distribution for averages is just the population mean, 10.9. So here I put 10.9 in the first entry, 10.9. For the second entry, that's the standard deviation of the sampling distribution for means. The central limit theorem tells us that that's the population standard deviation divided by the square root of the sample size. I need my calculator for that. So let's go to our calculator. And I just type in the standard deviation, which is 22.0, or 22, divided by the square root of the sample size, which was 3. I hit enter, and I get about 12.7. So I go to 12.7. You might want a second decimal point, but the second decimal point on this one, if you noticed, was 12.70. So that's the same as 12.7. Okay, I hit submit, and it says next use your mouse to shade the normal curve graph. I want to find the probability that the average is greater than negative 12.0. So I go to my mouse, and notice below it we see the x's, and you need to start at negative 12.0. So I move my mouse until I see about negative 12.0. So negative 11.96, that's the closest I can find to negative 12.0. So I push the mouse down, and then I move my mouse, keeping it pushed down all the way to the right, because we want all the stuff that's greater than negative 12.0. And I release the mouse, and I now have it shaded. It now says, now move the question mark either below the x-axis on the appropriate place to indicate you are looking for x, or above or in the shaded area to indicate you are looking for the area under the curve. We want to find out a probability. When you want to find a probability, that means we want to find out area. Had it said that we wanted to find a value of x such that the probability is, say, less than some number, then we would say that we want to find the x value, which is down there somewhere. But we want a probability, so I'm going to take the question mark, I'm going to drag it into the shaded region, and I'm going to release. And it says, nice work. Now answer the question. So we want the probability that the average of 3 items is greater than negative 12.0. So to find a probability with the normal distribution, I can use my calculator again. So I'm going to go to second, distribution, and then normal CDF. I hit enter. And the way the calculator works, I put the lowest value first. The lowest value is this number, which is negative 12.0. So negative, which by the way is different than the minus sign. So negative 12.0 if you want, or just 12, comma, and then the upper bound. Now notice with the shaded region, this goes all the way out to positive infinity. And for the calculator, we could use, say, 999, and that's close enough to positive infinity that it'll give us a close enough answer. So 999, maybe a fourth one just for fun. And then comma, and then the mean, which is 10.9 for this sampling distribution. So 10.9, comma, and then the standard deviation, which is 12.7. Remember, it's the standard deviation of the sampling distribution, not the standard deviation of the original population. So 12.7. I close the parenthesis, and I hit enter. And it gives me about 0.964. Notice that looks about right with our area. This is most of the area shaded in, and the whole area is 1. So I'm going to type in 0.964, 0.964, and I hit submit, and it says nice work. Next, describe the necessity of the normality assumption. So we have a bunch of choices. The first is the normality assumption is needed because only a single individual is being selected. Well, that's not true. We're selecting 3 individuals. The next is the normality assumption is needed because the sample size is less than 31. Well, we do have a sample size of 3, which is less than 31. So that is the correct choice. Just look at the rest of them to see where they would come about. So the first one would be had it been just one single individual. The third one is had the sample size been greater than 30. The fourth one is had the number of successes and failures been not both greater than 5. That would be the case if the survey question was a yes or no question. Then we're talking about the probability that a proportion would be, say, greater than a number. And that's not the case here. We're not talking about a yes or no question. We're talking about a quantitative question. And then finally, the last one is the same idea, but had the successes and failures been both greater than 5, then we would not need the normality assumption. So I'm going to click the normality assumption is needed because the sample size is 3, which is less than 31. And it says, congratulations, you successfully completed the problem. Click on the new problem button to try another one. So I could do more of these, and they're similar to what we just saw, except that the details would change. You might be asked for a sum, and if you ask for a sum, then the mean, the new mean, would be the population mean times the sample size, and the new standard deviation would be the population standard deviation times the square root of the sample size. We might also be asked for an individual, and then it's just the mean and the standard deviation would be the same as the population mean and the population standard deviation. We could also be asked to find some value of k such that the probability that x is, say, greater than k is less than a number. In that case, it would be similar, except that we wouldn't be looking for an area. We'd be looking for an x, and the question mark would go here. And then in the calculator, we'd use the inv norm, because we'd want the inverse, or the backwards, of doing this problem. So that's about all I have to say for this. I hope this makes sense. If not, please ask me, or ask your instructor if you have a different instructor, and we'll be happy to help. Thank you very much for listening.